SwayamPrabha. Digital India. Educated India.
So, friends, we are talking about project management in the course project production and operations management. Project management is very important. It is one of the types of production systems where the product is stationary and services moves, facilities moves to add value, resources move to add value. So, in this we talked about the importance of the project management. Why this is important? Because the performance of the project is measured in terms of cost, time and technical aspects of the project. We have talked about the scheduling issues which we are talking. In the scheduling, we have carried out the critical path analysis, and after performing the critical path analysis, if we have done the project crashing also, project crashing is required if we want to complete the project before the normal time. From the critical path analysis, we get the normal duration of the project, the duration in which the project can be completed in the normal, if the activity durations are taken as a normal duration. What happens in crashing is there are certain activities which can be crashed at a additional cost. So, the information was available to us for each activity, what is its normal duration, what is the crash duration, similarly the normal cost and the crash cost. So, with that we worked out the crashing. In the crashing, we tried to find out the reduced duration of the project at minimum additional cost. Now, we are in this session, we are going to talk about the resource leveling. In the resource leveling, the aspect is slightly opposite to the project crashing. Here we are having the constraints of the resources. Resources can be in the form of manpower, resources can be in the form of certain equipments, resources can be in the form of availability of the material or any other critical resource, or there may be a requirement of skilled persons or some kind of a resource which is having a constraint of that. So, in this what if there is a constraint to the resource, then obviously, if in certain periods more quantity of that resource is required, then in that case we have to shift the certain activities that may lead to the extension or maybe a extension of the duration of the project. Suppose the normal duration of the project is 20 days, but due to certain reasons one or two activity need to be shifted. So, project duration may increase by 1 or 2 days. So, that your resource requirements are uniform throughout the period. So, that is the kind of aspect which we are going to discuss in this particular session in this. So, let us see what is resource leveling. Along with the completion of the project within time and cost, the next lower level objective is to plan the project in such a way that the requirements of the resources, that is men, equipment etcetera, is uniform leveled throughout the project. Even if there is no constraint on the manpower, but still we would like to have the uniform level of manpower throughout the project. That is always economical. If we are doing too much hiring and firing, that will increase the cost of the project, and that is also increase the administrative burden on the project team. So, there are two issues which are involved here. There are two types of cases we can discuss here. In case 1, resources are available to meet the peak demand. There may be a peak demand, normal demand or peak demand, where on a particular day you require double the normal manpower or some equipment, but that is available. There is no constraint as far as the availability is concerned. But in this, the objective is to level the resource requirement without shifting the due date of the completion time. We want to see that due date is not shifted without shifting the due date. We are not shifting the due date, but we try to see that without any adverse impact on the performance of the project, can I achieve the leveling of the resources. As I said, that is always better. So, we achieve the level of resources without adversely affecting the performance in terms of completion time. So, that is the case 1 which we will take. There is a second case which is more critical in that sense. Resources are not available. Resources are not available. You need resources on few days, which is much more than the normal requirement, and there is scarcity or it is not possible to arrange those resources. So, in that case, and project completion date need to be shifted. In that case, because we first try to see that can I level it. First I will try it as a case A, reduce the peaks requirement and without shifting the due date, but if that is not possible, then we will try to shift the due date and we will try to see that resource requirements are within the available quantities or in the available form in which it is available. We should not violate that constraint at the time of scheduling, at the time of planning of the project. We should plan the project in such a manner that we are able to complete the project with the available resources. So, objective is to minimum shift in the completion, date and leveling the resources consumption within the given constraint, within given resource constraints. Okay. So, that is the idea in this particular case. So, very important aspect as far as otherwise there will be conflict at the time of implementation. You might have given a very good nice plan which looks very good on paper that you are able to complete the project in certain given days, but when it comes to the actual execution on particular days, the requirement of equipment is very high, which is not available. So, at that time the planning team and the execution team may have some kind of a conflict. So, it is better that we should take care of this particular aspect also at the planning stage. How many manpower, how many persons are going to be available on different days of the project or different weeks of the project. Similarly, how many generally problem comes with respect to the cranes and earth movers and other kind of construction equipments, heavy machinery, which is very difficult to get, their very limited supply, and the cost of bringing into the site and installing and making it ready for the use itself take few days and large cost is involved, and the hiring charges of this is also very high. So, in that case we should try to avoid this hiring and additional resources of that. We should try to work within the given constraints of that particular resource. So, that is a kind of idea in case B. So, we are going to discuss two cases, one where we will try to label the resources without shifting the completion date, and once that is done, even if there is a resource requirement more than the availability, then we have to shift the completion date, and we can the idea is to shift as minimum as possible the due date and try to bring all the resource requirement within the available resources. Now, let us see one a small example to understand this particular type of resource leveling. We are having a small example here which is having 7 activities, and we are having the immediate predecessors for this. So, these are the 7 activities we are having, immediate predecessor diagram is there and duration is given to us. So, this 3 set of information we have used in critical path analysis also. So, one additional information is here, that is the resources required, men required, how many persons are required for different activities. So, 4 persons are required for activity A, 2 persons are required for activity B, and the duration is 2 days, and we can say in the form of just for the sake of understanding. And on for activity C, 2 persons are required and activity duration is 2 weeks. For activity D, 1 person is required for 1 week only. Activity D required 2 persons for 3 days of this activity. Activity F require 1 person for 2 days. Activity G require 2 persons for 1 day. So, this is the data which is available to us about the project. Now, let us see, first perform the critical path analysis, and then from that we will see that how many persons are required. First we will draw the network, and then we will see that how many persons are required on different days of the project. So, let us draw, it is a very simple activity on arc network we can draw, starting with node 1. So, activity A, then we can have activity B, activity A, B and C has no predecessor. So, we can write activity B and then we can write activity C. So, these are the 3 activities which can start. Then activity D is coming from this. So, we can draw activity D. Similarly, from B we are having activity E. We are having activity E. I can draw a bit longer, that is activity E, because I have already drawn it earlier. So, I know that in one single go I would like to draw a very neat diagram, but otherwise you may require 1 or 2 iterations also to complete this kind of a diagram. That is very obvious, because in the beginning you do not know which activity is going to on which side of the diagram. So, after one iteration you get to know some idea, then you can readjust it and make it a good looking diagram. Then comes the activity F. Then comes the activity F. So, F also going to there is no activity after that. So, F is also terminating here, and from D we are having G. So, G is also terminating here. So, this is a small diagram which we are having, network diagram. So, now we can number it, there is no cross this thing. So, we can very simply we can write these numbers very nicely, we can say. So, we are having now 7 activities, activity A, B, C, D, E, F and G. So, this is how we can draw the network. Now, on this, as we are doing earlier, we can write the activity duration also. For 1 duration is 1, for B duration is 2, for C the duration is 2, for D duration is 1, for E duration is 3, for F duration is 2 and for G duration is 1. Okay. Now, let us work out the critical path, conduct the forward pass and then we will conduct the backward pass. Okay. Let us conduct the forward pass to identify the critical path. So, 0, 1, 1 plus 1 2, from this side 2, from this side 2, 2 plus 2 4, from this side we can say 2 plus 1 3, 2 plus 3 5 and 2 plus 2 4. Out of this 5 is the highest. So, 5 weeks is the project completion time. Project completion time is 5 weeks. I have taken a very small project, project completion time is equal to 5 weeks. Okay. Now, we can conduct the backward pass to identify the critical path. Change the, let us take the green color which we are using earlier also for backward pass. So, we can start with 5, that is the duration of the project, and if we want to complete this, this must be done by 4 and this must be come by 2, this must be 5 minus 1 4, 4 minus 1 3 and 2 is 0 and from this side we are getting 2 and from this side we are getting 2, out of the 3 minimum is 0. So, my critical path is this, then 2 and 2 are coming here. So, this is my critical path and then 5 and 5 are coming here. So, that is my critical path. So, critical path is activity B and then activity E. So, that is a critical path. So, the critical path is 1, 3, 6, activity B which is having a duration of 2, activity E which is having a duration of 3. Okay. So, this is my critical path, B and E are my critical activities. So, now we will see that how many manpowers are required on 5 different weeks. In week 1, how many persons are required, in 2, 3, 4 and 5, how many persons are required. We will do that kind of a analysis here. So, same diagram which we are having in the previous slide. So, I have already prepared that. So, we are keeping it here. On this diagram, one additional information has been added, that is the number of, I am ticking with green color. The tick with green color is number of men required, number of men required. We can write on this diagram also for the sake of clarity. We can use some color we can use blue color here. So, number of persons required for activity A is 4, for activity B it is 2 persons are required. So, we are writing 2 along with this. For activity C 2 persons are required. So, we can write 2. For D 1 person is required, we can write here. For E 2 persons are required. So, we can write here. For F 1 person is required, we can write here. For G 2 persons are required, we can write here. Okay. So, this is how on the network now we are having all the information of the which is given to us in the tabular form. Now, we have taken that information on our network activity on ARC network. So, from this now let us carry forward to this particular sheet. So, 5 days is the project duration time. Let us see how many persons are required on different days. Activity 1 will start on 0 and will end on 1. Okay. Activity this will start on 0 and end on day 1. So, we can plot activity A this. Okay. So, this is my activity A and it requires 4 persons. It requires 4 persons. Now, we are writing the 4. Time will come here. This is the time scale. So, I need not to write time. I will write number of persons required. A requires 4 persons. Now, I can draw B. B the duration is 2 days. So, I will draw the B. Duration of the B is 2 days, which is reflected here, and number of persons required is 2. So, in this we are writing the number of persons. Okay. So, after this we can draw C. C also required 2 days. So, I can go here, I can take here. So, this is my C, which is also required 2 persons. Okay. So, now this after A we are having D. D the duration is 1 day and it required D require 1 person. Okay. Now, after that D we are having G. G has a duration of 2 weeks. G has a duration of 1 week. So, we can draw G here and G requires 2 persons. Okay. So, very easy to do. From B we require E, the followed by E, and E has 3 days. So, we can plot E also here and we can bring it here and we can draw it here. We can rub this little bit which is extra. Okay. So, E requires 2 persons on each in each week in each period. Now, after C we are having F, the duration of this is 2. We are having F, the duration of which is 2 and persons required is 1. 2 we have plotted here and the person required is 1. So, this is how we have deployed the manpower on this our Gantt chart. On the Gantt chart we have put the manpower with early start schedule of the activity. If the activities are starting as per the early start schedule, then this is going to be my manpower requirements. Okay. Now, we can count the number of persons required on different days, different weeks of the project that we can count now. On day 1 we require 4 persons for activity A, 2 persons for activity B and 2 persons for activity C. So, 8 persons are required on day in the week 1. So, this is time in weeks and this is our Gantt chart. So, this is our Gantt chart with number of Gantt chart with number of persons required, number of persons required. Okay. So, like this. Now, on day 2 how many persons are required? 1, 3, 5. 5 persons are required on day 2, week 2. On week 3 how many persons? 2 plus 2 4 plus 1 5. 5 persons are required here. On next week how many persons required? Nothing is required. 2 plus 1 3 persons are required in this week, and in the last week we require 2 persons. So, this is my requirement. 8 person in the first week, 5 person in the second week, 5 person in the third week, 3 persons in the third week and 2 persons in the second week in the last week. So, this is how you will find that maximum requirement is 5, minimum is 2 and how many total persons required? We can count that also 2 plus 3 5, 10, 15, 23. We can check also that we have done whether the right calculations or not. We can take this table and we can take the help. 4 persons are required for 1 day, 4 into 1 4, 2 persons are required for 2 days, 4 manpower man weeks are required, 2 persons are required for 2 weeks, 4, 1 is required for 1, 2 are required for 3, 6, 1 is required for 2 weeks, 2, 2 are required for 2. What is the total of this? 4, 8, 12, 13, 19, 21, 23. So, total man weeks required, total man weeks required to complete the project is 23. So, we can check that all 23 has been properly accounted for in this our Gantt chart analysis. So, that is the first aspect which we have, which we can do, that now we have identified the persons required. And first we will do the case A, where we would not like to increase the manpower and we will try to level it. We will now discrepancy is minimum is 2 and maximum is 6. We will try to see that some of this manpower is shifted and so that a more uniform looking, level looking manpower deployment is done and without shifting the due date. Within the 5 days we would like to complete the project and see that the requirement is leveled. Okay. Now, let us see how to do that. So, I have repeated the same which we have done in the previous slide. So, we have I have repeated the same thing here. So, our observations from this on the previous page is now we are going to take the case A. Okay. The previous case is we have done as per the early schedule what is the manpower requirements. Now, we will run the case A, where we will say that without increasing the completion duration, can I complete the project in lesser number of time. Can I, this is the week 1, 2, 3, 4 and 5. Okay. So, we will see that can I complete the project in lesser duration in the same duration, but with the less peaks and valleys. Right now, 8 is the maximum requirement, 2 is the minimum requirement and total man days are required is 23. Do not get this thing somewhere I am speaking days, somewhere I am speaking weeks. So, it is a time unit basically, does not make a difference as far as analysis is concerned. Okay. So, in case A we have already written, though there is no constraint of the manpower, I can have 8 also on this date, there is no problem. Can we label the requirements without increasing the project completion date? So, that is the challenge here. So, let us do that. So, B and E are the critical activities, we cannot do anything to them, because if we are shifting any activity B and E, then our project duration will get shifted. So, first step in this case is I will translate B and E as it is, and let me draw the time scale also. This is 5, this is 4, this is 3, this is 2, this is 1. So, let us see that we are having we are having 2 days for B and 2 manpower for B for 2 days and E 2 persons for 3 days. So, we will not shift these 2 activities because these are on the critical path. Now, let us see how to shift these activities, so that my manpower requirement is uniform. A require 4 persons. So, I have to shift A little bit, so that my requirement of A is not coming with this. So, I would like to shift activity A by 2 days because I am having 2 days cushion also. So, I will shift this A here and 4 persons are required here. Once I have shifted, I do not have any cushion. So, I can plan D here with 1 person and I can plan G also with 2 persons. Okay. Now, let us see, there is no allocation here, this is blank, there is no allocation here, this is blank. Now, let us see, can we shift a C, 2 person we can keep it C here only. C requires 2 persons. So, we can keep it like this only. Now, here we are finding there is a load of 6, there is a load of 6 persons and here there is a load of 3 persons, here there is a load of 4 persons. So, here it is a load of 3 persons. So, I would like to bring this F has 2 periods. So, I would like to bring F here, because here already 4 persons are required. So, I will not try to have it here. So, I will have F here. Okay. So, 1 person is required for F, I would like to keep it here. Now, let us see how many persons are required in different weeks or days of the project. So, here we require in week 1 we require 2 plus 2 4 persons, in 2 also we require 4 persons, here we require 4 plus 2 6 persons, here we require 1 plus 2 3 plus 1 4, here we require 2 plus 2 plus 1 5 persons. Okay. So, this is how we are able to shift. Now, what is the total, again check, there should not be any mistake, 4 plus 4 8 plus 6 14 plus 4 18 plus 5 23. So, this count is matching. So, this is okay. So, what is our observation? We are able to arrange the manpower, we are able to level to some extent the manpower. So, that now rather than 8 is the peak, now the peak requirement is maximum requirement is shifted to 6. Total project duration remain to 5. Total man days requirement will remain 23, that will not change in any case, and minimum requirement is now 4, and on 3 periods you are requiring 4, 2 extra is required here and 1 extra is required here. Whereas, in this case you will finding that you found that there were more unevenness, now there is a better evenness in this particular case. So, that is the case of leveling as a case 1, where we have not allowed the project duration to be shifted. Okay. So, that is the one exercise which we can perform, case A. Now, our total project duration is remain same 5, maximum requirement is 6, minimum requirement is 4. So, very easy to do, only thing is we have to see that there should not be wherever more manpower is required, we should not assign more other activities along with that, and we should see that we can only shift those activities which are not on the critical path. So, you will observe here that we have first marked the critical activities, that is B and E. So, we have not disturbed the B and E. If you see here B and E, so it is coming at the same place, E is also coming at the same place. So, we have not disturbed the activity B and E which are on the critical path. Just have a look here, B and E were on the critical path, B and E were on the our critical path. So, and 5 is the 2 plus 3, 5 days is the duration for that. So, we have not disturbed the critical path activities, they should be kept as it is. So, that is the first principle which I have to see in case A, where we are leveling the resources without shifting the due date. So, that is the foremost, that we should not disturb the activities on the critical path, and then around that we should try to adjust other activities. So, that my peak requirement is reduced. Then we will see that we are having a cushion of 2 days here for this activity A, D and G. So, can I shift? So, we can shift that. Activity C and F cannot also. Further, we have to keep in mind very important point which we should keep in mind. I cannot break the activities in 2 parts. I can say the half the activity is done, then there is a break, then another half is carried out. No, that is not permissible in resource leveling. We should keep that particular precaution, though it is not coming anywhere in the previous discussion, but I am giving you that particular hint here or precaution here. We cannot divide the activities into two parts. We may say that see, let us perform this here and half of this we can do after that. You cannot do that, that is not permissible in the project management. The complete activity has to be carried out in continuation. So, that aspect we have to keep in mind. So, once I have done the critical activities, then I can see that we are having a slack of 2. So, I have shifted A, D and G activities by 2 weeks. Similarly, I found that there is a slack available of 1 week. So, I have shifted the activity F also. I have shifted the activity F also, and also we have to see that if there is any precedence relationship. That is why I have taken, if you see that we are having 3 distinct paths. This is a very simple network. We are having a 3 distinct path, there is no crisscrossing also. If there is any crisscrossing, obviously in that case we have to see the precedence also in mind. Suppose there is some kind of a precedence is there that you have to do that activity before that, then the freedom available in leveling will be reduced. So, here we are having 3 independent paths. So, that is why it is not affecting the that aspect is not there. So, I have independently done their shifting. So, without affecting their, because they are not having any precedent constraint, they are having 3 independent paths available in the network. So, in that manner, this is the case A, where we are having the condition that I should not change the project completion time. The project completion time is kept as it is without any shifting of that, and but we are able to make the smooth requirements. We are able to make the smooth requirements of that. There is a smoothness index also we can calculate if we require. We can calculate the smoothness index also. Smoothness index, that is S max under the root S max into S I summation of all and square. Okay. So, in this case, if we want to calculate the smoothness index, we can do that also. Our x max is 6. So, here in this case the smoothness index will be, we can do that 6 minus 4 whole square plus 6 minus 4 whole square plus 6 minus 6 whole square plus 6 minus 4 whole square plus 6 minus 5 whole square. So, this will be 4 plus 4 plus 0 plus 4 plus 1. So, this will be 4, 12, 4, 8, 12, 13 under the root 13. And in this case, if we want to calculate the smoothness index, we can do that also. In this case, my smoothness index will be or you can say leveling index can be same way under the root S max in this case is 8. So, 8 minus 8 whole square plus 8 minus 5 whole square plus 8 minus 5 whole square plus 8 minus 3 whole square plus 8 minus 2 whole square. So, this turns out to be 0, 3 into 3 9, 3 into 3 9, 5 25, 6 36. So, this will turns out to be 36 plus 9 20 45, 45 plus 25 50 70 79 under the root 79. So, we are able to smoothen the manpower requirement from under root 79 to under root 13. We can calculate that also. This is almost 9, this is almost 8 point something, smoothness index 8.89, whereas this is 3 point something, 3.5 or something, we can calculate that. So, this is how we are able to smoothen the manpower requirement, or we are able to level the manpower requirements. So, you might recollect that smoothness index we calculated in line balancing also, where we want that all the workstations are having equal work content. So, here also we want different periods of the project has as far as possible same number of manpower requirement or resource requirement. So, we are drawing the clue from that only, and we are calculating the smoothness index. Okay. So, smoothness index we can calculate for the in the initial case it was when it was early start schedules we are having 79 under the root, and when we are able to shift certain activities on a latest start schedule, and then we are able to smoothen the project manpower requirements. Now, let us take the case 2 where we have having a constraint. If the maximum available manpower is 4, then what to do? Available man, you do not have 6 persons available, you require maximum 6 person on a particular day, 5 persons on a other day, but the manpower available is maximum 4 is available. Now, obviously, if 4 persons are available and 5 is the period required, 23 is the total manpower required, it is not possible to produce to complete the project in 5 days, because 4 into 5 20, you need 23. So, the project is going to be shifted by 1 or 2 weeks. So, that we have to see, otherwise 4 into 6 24, the minimum is 6 weeks, 6 into 4 24, but if there is some other constraints are there in the network, or because of the criticality of the activity or precedence, it may take more than 6 also, but if you are having only 4 person, theoretically minimum number of days required you can very easily calculate. Theoretical number of days required, theoretical number of days or periods or weeks required is 23 divided by number of persons available, that is 4, that will comes to be 5.75, and that is 6 days or weeks are required to complete this project, if you are having constraint of the human resource. Okay, let us do it, how to go about it. So, this is what we have done in the step case 1. Now, let us see further how to adjust the project, so that we are not consuming more than 4 persons in the project. Okay. So, let us draw for the sake of we can take the draw the line corresponding to this. This is 5th day, this is 4th, this is 3, this is 2, and this is 1. So, that is my time scale. We can draw one more, 6 is also going to be needed. So, first we can draw 3 lines going up to 6, 3 tracks going up to 6. Okay. So, now what to do? Let us 4 persons are here. So, these 2 weeks we can keep as it is, nothing is required. We are already requiring only 2 for these activity, B 2 and C also 2. So, 4 persons are required here, 4 are required here, which are available to us also, which are available to us. Okay. So, there is nothing is required to be done for this. Now, here I need 6 persons. So, but I am having only 4. So, activity E I have to shift by 1 day. Activity, so I can have this A as it is, 4 persons are required, but I cannot start E here. I have to keep this track vacant, I am not allotting. So, E will start from this point onward, and then 3 is required. So, it will go up to 6. So, E 2 persons are required and it will go up to this. So, that is the requirement of the 2 persons on from day 3 to day 6. Okay. So, that is number of days 2 1 or let me change this color of these numbers days. So, or we will write the manpower later on. We will write the manpower later on with some other color. Let us do it first, this assignment leveling of the resources, not more than 4 person I should consume. Now, so on day 1 we have 4, on day 2 we are having 4, on day 3 we are having 4. Now, I cannot do anything here, I have to kept this also blank. Now, I can assign 2, I am having a cushion of 2 persons I can additional activity I can perform here. So, I can G required 2. So, I have to first book the G. So, that 2 already there, 2 more I have to book the G here. So, I can book the G here for 2 person. So, that on this day also I am having now quota is complete, quota is complete, quota is complete, no more assignment on this. Now, I am left with the 3 activities, that is 2 activities, that is D and F, both are requiring 1 person. So, I can do in any manner. There is 2 activities, F require 2 days and 1 person is required. So, I can assign F here, 1 person is required. So, I can assign 1 F here. So, now this is 3, this is 3. So, I am having a cushion available of I can assign D here, I can assign D here 1 person, and this also I can kept it vacant, there is no requirement. I cannot assign G here because G required 2, then that will violate the constraint. Now, here 1, 2, 4, here also 2 plus 1, 3, and here you require 2 plus 2, 4. Let me change the color and I can write the number of persons required on different. So, in period 1 I need 4 persons, in period 2 I need 4 persons, in period 3 I need 4 persons, here period 4 1 plus 2 3 plus 1 4, here 2 plus 1 3, and here 2 plus 2 4. And I can mark this also as a vacant, we are not doing anything here, we are not having any activity here. So, this is my new deployment of activity. Some activities are working on early start and some activities are on working on the latest start and latest finish also. This is also we have shifted, though this activity E is on the critical path, but we have shifted by 1 day because I am not having the sufficient resources to process this particular job. So, because of the lack of resources, I have to shift the even the critical activity by 1 week. So, that by manpower resource constraint is not violated. We can count here 4, 4, 4, 4, 3 and 4. Okay. So, this is how we can smoothen the line. So, 23 persons are required. What are our observations? If there is a constraint of the manpower or some other resource, the duration of the project will be extended, and so that that is one of the important observation. Now, we can calculate the smoothness index for this also. You will find that smoothness index is further improved, is equal to, as we have written the formula here in the previous slide, S max minus S I whole square summation of that, and then under root. So, this is equal to, in our case, in this case maximum time is 4. So, 4 minus 4 whole square plus 4 minus 4, 4 minus 4 whole square, this is also 4, let me correct. Plus third is 4 minus 4 whole square, fourth is also 4 minus 4 whole square, fifth is 4 minus 3 whole square, plus fifth is 4 minus 4 whole square. So, that gives you 1, rest all are 0. So, under the root of 1, that is 1. The smoothness index is ultimate requirement is smoothness index should be 0, all are balanced. If all are having the same workload, then the smoothness index will be 0. But in this case also it is very close to 0. In first case we were having the smoothness index of under root 79. Then first level of leveling which we did, the smoothness index reduced to root 13, and now we are able to reduce it to root 1. So, that is how the leveling we can do, and that is one of the very important requirements in the projects. So, friends, with this we are completing the various aspects of the critical path analysis. So, in this first we try to develop the network of the critical path analysis for that purpose, then we perform the forward pass and the backward pass. So, that I can determine the critical path and as well as the critical activities and the duration of the project and the duration of the project. From that, then we did the project crashing, and from the project crashing, so that I can reduce the duration of the project if required at some additional cost. Then next we did the resource leveling, if there is some constraints of the resource, or if we want that resource utilization should be uniform throughout the project, that is always less expensive. So, from that perspective we did the resource leveling. We studied two cases, case A where there is no constraint of the resources, and but we want to see that they are leveled. In case B, we are having a constraint on the maximum resource available. So, in that case there is some extension of the project, there is some project completion date is shifted, is duration increased from 5 weeks to 6 weeks. So, that is the kind of study we have done. Now, we are going to take up a very important aspect, that is earned value analysis. We will take a very important aspect, that is earned value analysis. As we said in the beginning, the cost and time are two very important factors in the performance of the project. We have to see that, we have to achieve that, see that project is completed within the given time frame as well as within the given cost budgets. So, that is very important. Obviously, there is third parameter also, that is performance, but performance is more on the technical fronts and other factors, but two important factors for which we have to keep a control on the activity, that is more engineering or technical aspects of the performance, but time and cost is same for each and every project. The project to be completed within the given time schedules and within the given budgeted amount. So, that is the requirement in each and every project. So, from that perspective, we are doing this earned value analysis here. In the earned value analysis, we use the three key pieces of the project information. What is the planned value, and what is the actual cost, and what is the earned value. So, we will see, we will compare the three. What is the planned value? That means, how much amount of work should have been completed by such and such date, and what is the actual cost which we have incurred, and in the given time how much is the value we have earned out of the plan. So, there are three factors which are independently playing here, and we have to develop the relationship between them, and then we will see the various types of variances. If there is a difference between the actual cost and the planned value, if there is a difference between actual cost and the earned value, then we have to see that why this variance is there, and we have to take the counter measures also. So, in that context we will have this earned value analysis. So, let us see first what is earned value. Earned value is the percentage of the total budget actually completed at a point in time. So, we are having the Gantt chart available or other control mechanisms available, on which we see that what should be the completion of the activities and how much activities have been completed. So, from that we will see that how much value has been earned. So, earned value is the percent of the total budget actually completed at a point in time, at the point of review, how much total value has been earned by the project. This is also known as the budgeted cost of the work performed. Budgeted cost of the work performed. We will see with the help of one example, you will be more clear in that. Earned value is calculated by multiplying the budget for any activity or the work package by the percentage progress. So, it is percentage complete. If the work is completed 40% and budget is of 3 lakhs, then we can say that 40% is completed of 3 lakh budget. So, the total earned value is 1,20,000 rupees, 40% of the 3 lakhs, that is 1,20,000 is the earned value by the project. So, that is the concept of the earned value. Now, let us take one example and then we will see the analysis also. There is an example, there is a work package, we have taken a very simple example, installation of 600 new air conditioners in newly built housing project, and 300 ACs. Out of the 600, we have done a review on a particular date, that is the total time available to complete the project is 40 days, and a review was carried out on the 30th day. A review was carried out on the 30th day. So, we have to keep these numbers in mind. 600 new air conditioners were to be installed in 40 days and on the 30th day review took place, and at the time of review it was found that only 360 ACs are installed so far. That means progress is 60%. So, only 60% of the work has been carried out there, though the time consumed is 75% of the time is consumed, but the work accomplishment is only 60%. Then further we have to keep in see that how much money has been spent in completing 60% of the work. The budget for this work package is 3 lakhs. Total amount for 600 is 3 lakhs, and the earned value thus is 60% of the 3 lakhs. We that 60% of the 3 lakh, that is 1,80,000 is the earned value. Just like percentage complete, 60% is the completion, and the budget was 3 lakh rupees. Budget was 3 lakh rupees. So, it is 1,80,000 is the so 1,80,000 is the earned value for this. Okay. So, now let us see what can be done. And actual cost incurred is also 1,98,000. So, you will see that this is how the projects are mismanaged. On one side 75% work should have been completed, it only 60% is completed. For the 60% work, the amount spent should have been 1,80,000, but in actual 1,98,000 has been spent. Here we are talking a very small project. Think of a project of few crores where highways and other things are there. We can say that 600 kilometer road to be built, and the total project is of maybe 300,000 crores or 3 lakh crores or something like that. We have to build a road of 600 kilometers. We can convert this as a 600 kilometer road to be built, and we know that roughly 1 crore is required to build 1 kilometer. So, 600 crore is the budget of this. In terms of million, we can say that 6,000 billion rupees is the budget for this particular project. Sorry, million is the project for this. 600 million is the project to complete this budgeted cost which is given to us, and then we can see that what is the progress at a particular point of time. Okay. So, we can, rather than considering our air conditioner, we can take any example, or there may be any activity or any such thing. This is for the sake of convenience, for the better understanding, we have taken very small numbers and a simple project. Okay, but this can be translated to any other project, and their project may have multiple activities also. You have given the project for not only installation of the air conditioner, but also along with the cameras, along with other security devices, internet wiring and cabling connections, etc. So, there may be multiple activities given to a particular worker, but the project consists of multiple activities in that, and then we have to see that how these activities are performing. So, we can, each of these activity we can see that what is the progress in terms of expenditure, actual cost, and in terms of number of days spent on that. So, moving forward, so we have to keep this number 600 is the total quantity, and 3 lakh is the budget. 60% is completed on the 30th day, and earned value is 1,18,000, and actual expenditure is 90,000. So, I can number it. So, first information is 600 new air conditioners are to be installed, consuming budget is 3 lakh rupees, and the time given is 40 days. So, these three set of information first we have to keep in mind, that is the budgeted time and money for this, and the work, time, money and time. Now, what let us see the actual. Actual, we did a review on actual. We have completed 600 ACs in against a target of 600. We spent amount of 1,98,000, and this is in 30th day. And from this we will calculate the fourth parameter which we have calculated, what is the earned value of the work completed. What is the earned value of the work completed, that is 60% of 3 lakh, 1,80,000. This is not given, this we have to calculate. So, this is how we have to keep these 7 numbers in mind when we are doing the earned value analysis. So, this is the planned earned value. We should have gone as per this curve, So this is the completion of installation of 600 ACs, and on actual we have done 60% of that. So, we have this is the work which has been completed and this is the cost which has been incurred. Okay. So, from this we can make out. So, this is the gap, this is 1,98,000 and this is 1,60,000 is the amount of work which has been completed by spending. So, that is called spending variance. So, this is the spending variance between the two. This is the spending variance between the two, and by this time when we have done the review, this should have been completed by this time. This much work should have been completed, which we have completed in this time frame, that is in 40 days, that should have been completed 30 days, that should have been completed much earlier on this. So, that is the time variance which we are having. Okay. And similarly, we can have the time variance, schedule variance and cost variance. So, the cost variance also we can calculate, that is the overrun in the cost. How much is the overrun in the cost, that also, that is earned value minus the actual cost. So, 1,98,000, that one value is 1,60,000, actual is 1,98,000. So, that is the variance that we will see on our next sheet. If the project is going in this manner, we are not putting any control over it, the cost will increase by this much. This is the expected actual cost, this is the budgeted cost, this is the actual expected cost. If we are not making any corrective measure, if we are not putting any control, the cost may increase also. Okay. And project may get delayed also. The project if going like this may take some time like this, more than the what we have planned. Now, let us calculate these parameters. In case of installation of air condition, earned value is 1,80,000. And that is 60% of the work is completed. Actual cost incurred is 1,98,000. Planned value in 30 days work was 2,20,000 worth of work should have been completed, 75% of the total work. Actual time of work performed is 30 days. This is the review period when we are taking. Scheduled time of the work, this much work which has been completed 60%, it should have been completed in 24 days. So, what is the cost variance? Cost variance is 1,80,000 minus 1,98,000. So, there is a negative cost variance, there is a overspending on that. Similarly, there is a schedule variance of you are behind schedule by minus 45,000 rupees. You should have completed the work of 2,28,500, but you have done the work only of 1,80,000. So, 25,000 is the 45,000 is the schedule variance. Time variance 6 days. You should have completed this work by 24th day. Now, you are completing this work in in the 30 days. So, that is called the schedule time variance. So, this is how we can do this analysis. So, we can also express these variances in the form of ratio also. We have taken here in the form of difference also, but if you are having only single project, then you can take in the form of difference also, but if you are managing multiple projects or in the project is having multiple activities, then the difference is not a good measure. We can take the ratios in the same manner where we have taken EV minus AC, we can take the ratios. Use ratios is particularly helpful when comparing the performance of several projects or several activities of the same project. If the earned value chart shows a cost overrun or performance underrun, the project manager must figure out what to do to get the system back on the target. As I said, if no corrective measure is taken, the project will get over cost also and project will overrun also. Option may include borrowing resources, you should add more resources, holding a meeting with the project team members to suggest solution, or notifying the client at least that project may get delayed. So, that is or there may be a budget overrun. So, with this the various questions which we can answer, what is the problem causing the variance? So, this can be a managerial exercise, this can be an engineering exercise, this may be some conflict management, or something is we have to see what is the real cause of this variation. We can do the root cause analysis for this. We can perform the root cause analysis for this. And then what is the impact on time, cost and performance? At present you are taking a review. So, how it is going to impact the completion time, completion cost and other performance aspects of the project. What is the impact on other efforts? if I take other efforts, how it will going to improve the situation. What corrective actions is planned or underway? Is there any corrective action already taken, and we can see that in coming times it will show the results and project can be bring back to the planned situation. What are the expected results of the corrective actions? So, that is we can study that. So, friends, this earned value concept is very very important in project management, that will help you in controlling the time and the cost of the project. So, that in between at a regular interval we should perform the earned value analysis to see that project is as per the schedule. So, in the next session we will take the PERT exercise. Thank you very much.